Molecular hybridization is born of an atom's need to have its bonding electrons all be of the same amount of energy. If they're of different amounts of energy, then really weird things can happen to the atom once it's actually bonding in a molecule, and it will distort it, and it would be really, really bad. So it ends up making these hybrid orbitals. So again, all of those bonding electrons around an atom all have to have exactly the same energy. And unfortunately, all of those electrons are coming from different types of orbitals. Some are going to come from s orbitals, some are going to come from p orbitals. It's even theorized that some can come from d orbitals as well. So they're all going to kind of mishmash together and create these weird orbitals. So the s orbitals will kind of gain some energy. They're considered to be low energy orbitals. P orbitals will lose a little bit of energy into this weird hybrid mishmash. And there are three basic types that you need to know, although there are more out there. The basic types that you're going to need to know are sp3, sp2, and sp. So basically, sp3 is a hybrid orbital made of one s and three p orbitals mishmashed together. The sp2 is made of one s and two p orbitals, and sp is made of one s and one p orbital. So how are we going to figure out what kind of hybridization exists in every molecule? Well, what you're going to need to focus on is areas of electron density around the central nucleus. So in whatever Lewis dot structure you're dealing with, find the central atom, then count how many areas around it are occupied by either bonds or by lone pairs. Now, the weird thing about hybridization is that when you're counting in a bond, single, double, or triple bonds all still count as one single area of electron density. And don't again forget that the lone pairs still count as an area of density. So if a central nucleus is going to have sp3 density, or sp3 hybridization rather, it's going to have 4 areas of electron density. sp2 is 3 areas of density, sp is 2 areas of density. Let's practice with some examples here. So here's methane, CH4. I'm going to focus in on the central nucleus, the carbon, and count the areas of separate electron density. Well, it has 4 individual bonds. Each one of those bonds counts as an area of density. 4 areas of density, that's sp3 hybridization. Here's CO2. Now CO2 has double bonds. Well, each double bond only counts as 1 area of density. So technically there's only 2 areas of density around this carbon, the central nucleus. 2 areas of density, this is sp hybridized. What about ammonia, NH3? Well, it has a lone pair, that counts as an area of density, and it has 3 individual bonds. Each one of those counts as well. So that's 4 total areas of density. I would say that ammonia is sp3 hybridized. What about BF3? It only has 3 bonds, no lone pairs, 3 areas of electron density around it. I would say that this guy is sp2 hybridized. And what about water? Water has 2 lone pairs. Each one counts as an area of electron density. 2 bonds, 2 more areas of density. 4 areas of density total. That's sp3 hybridization. So I hope that this was a little helpful at trying to at least assign the molecular hybridization. Now, it won't be until later, probably when you get into college, that you'll actually learn about a little bit more about what all this hybridization means and how to determine it and some further ramifications. But for right now, make sure that you can identify what type of hybridization exists in the molecules that you're drawing.